Wonderful. Okay, can everyone hear me in the back? Way in the nosebleeds back there? All right, cool. I hope I'm not going to bother all the students who are studying around us. Wonderful. Okay, cool. My name is Jonah. This is the Instant Futures talk. I am a new research engineer at the DVIC. And I just started a couple or 3 weeks ago, maybe. And I'm here to talk to you about my project and hopefully inspire you and also maybe answer some questions after, or inject some exterior or some outside ideas into this already very cool space. Does anyone have any questions before we get started? All right. Okay, that was a trick question. There's no questions. Don't worry. There's no test. There's no quiz. I have to stay inside this box or else I won't be recorded. So you're going to all help me stay inside the box, okay? Wonderful. Okay, so my talk is called Prepared Instruments for Computer Alchemy. And I want to tell you about some projects that I'm inspired by. On the left is a project by Clement Valla called Postcards from Google Earth. I'm not sure if you've heard of it, but it's Clement Valla went on Google Earth and found all sorts of moments where Google Earth kind of had difficulty understanding what was happening on planet Earth. And so here you can see that Google Earth tried to looked at a bridge and thought, well, I mean, typically terrain doesn't have like these like overhanging tiny strips, right? So I mean, that's probably just like some weird visual effect. I should flatten this. And so he collected all sorts of moments where Google Earth kind of like, even though it's armed with all these like very sophisticated algorithms, kind of had difficulty interpreting the world around us and led to a completely absurd result that for any of us would be obviously incorrect. So there's a kind of funny contrast between this like super serious machine that's got like all these computers behind it, and then it's kind of like looking at the world being like, I'm gonna map all of this, and then it's like doing kind of like silly mistakes that for a human are like, that's ridiculous. Football tackle. All right, I feel protected because I have my own body, my personal bodyguard. If any bullets are coming my way, Xiao's going to catch them first. This is another project. This is another example of a really cool Google Earth project that was carried out by Aaron Besler. Nice. All right. Yeah. Fortifications. Yeah. We're building a bunker one step at a time. This place will become a bunker. So this is another really cool project. So Aaron Besler is an architecture professor at UCLA. And she had this brilliant idea. She took a camera and set it to follow the resolution frontier between an urban space and a non-urban space in Google Earth. So if you think about it, there's a limited amount of computer resources to represent all of the world that we live in, right? So you need you need more memory to represent an urban space because there's more towers and stuff like that. And she found the precise moment where Google says, well, okay, like let's just say that's the end of the city because like we have finite resources, okay? And what she found was by putting a camera along this border between the urban and the non-urban, she was able again to find all sorts of kind of absurd moments where Google Earth once more chops buildings in half, or things that are like floating in the air suddenly are collapsed into 2D. So once again, computer vision having difficulty understanding the human world around us, leading to absurd moments. This project on the left, are you still with me? All right. Okay, cool. This project on the left is a really beautiful project by this artist in Berlin. And what he did was he went around and he found TVs that had been thrown out. So like TVs on the street. And he took a camera, a very special high-speed camera, and he turned the TVs off. And he took a picture of right at the moment where the screen collapses. And he did this with like tens of not computers, television sets. And then he made this beautiful, absolutely sublime series of these moments of image death. And what he found is that each television has its own kind of idiosyncrasy. It's almost like each television has its own soul, and that he's taking a photo of this and trying to capture this kind of ghost in the machine moment. And they're also just beautiful. And the photos, in addition to being aesthetically interesting, show the functioning of the machine. You can actually see the way that the machine scans with the photon gun, how it actually makes the illusion of an image appear on a screen. So I really like this combination of finding like objet trouvé, plus finding idiosyncrasy in machines that we don't typically think of as being idiosyncratic or having kind of a personality, and then making an absolutely sublime series out of this, which is absolutely beautiful in my opinion. I'll skip the other one. Okay, we're good. I'm gonna have to speed up. Okay, so does anyone know what a prepared instrument is? Okay, anyone out there maybe studied experimental music? Why don't you tell us? What's your prepared instrument? Awesome, thank you so much. What a promising student. Sweet. That's so cool. Okay, so did everyone catch that? So essentially, a prepared piano is where you open up a piano and you put stuff in the piano, things between the strings, okay? So bolts, nails, spoons, yeah, pâte modelée, yeah. And essentially, this changes the nature of the sound that comes out of the piano. So instead of having your typical piano sound, you can actually achieve a whole new range of sounds, like percussive sounds, like almost like a drum. So you can have like a piano that's like has a drum inbuilt drum set, so beyond just the coolness of how badass you need to be to open up a piano and like walk inside and throw stuff in and then compose experimental art. There's like a really interesting conceptual moment here, which is that, okay, I'm an artist. This is the instrument that's associated with my medium. So I'm a composer, I'm a pianist. And instead of just using the machine, the computer, or sorry, rather the piano to make sound, I'm going to actually explore the instrument as a site itself. So I'm not just going to use the instrument to make sound, I'm going to open up the instrument itself. What can I learn from actually getting my hands inside of this instrument? So instead of taking it for granted that the instrument exists and behaves in a certain way, I'm going to actually break the fourth wall, enter inside the machine, and start to modify and start to have a kind of dialogue with the instrument, with the machine. And that's kind of a similar theme with Oulipo, which I'm sure you've all heard of, the experimental literature collective, whose members include Raymond Queneau and others. This piece, 100 000 milliards de poèmes, was an example of taking a series of sonnets and slicing the pages such that each line of each sonnet could be turned independently. So this was kind of a questioning of like, well, we've taken for granted that the atomic kind of particle of a book is the page. But what if it were not? What if we were to take the guillotine, which is very charged in French culture, and what if we were to use that to find like a new atomic element of the book? And if it wasn't the page, what else could it be? And of course, when you slice all of these lines, you can recombine your own poems. And this piece was specifically conceived to work with different combinations of poems from different pages. So again, this literary collective is questioning the object that's kind of associated with their medium, which is the book. And then they're saying, how can this book function differently? And what could we learn if we made this book function differently? Like, what could we unlearn? So a lot of questioning of assumptions, which is something that artists try to do. They try to question their assumptions, and a lot of techniques exist to try to get out of your own head. All right, sweet. And then last example, all right? Stay with me. Is Stan Brakhage is an experimental filmmaker. He took plants, dried plants, and he put them in the video recording machine. Whoever thought of doing that? So he found plants that were dried that were so fine that they could actually fit inside the machine itself. And so he made experimental films that were just inconceivable because he was not using the machine properly. He was interested in rethinking the way the machine could function. And as you can see with all of these examples, there's an interest in the materiality, the actual physicality of the instruments themselves, and getting your hands inside these machines. Okay, that's enough of me talking. Now I'm going to talk some more. So my project started with a prepared plotting machine. Do you guys know what a plotter is? Are you too young to know what a plotter is? It was way back in the 70s. We had machines that would actually draw out on big sheets of paper. So like if you were an architect and you wanted to submit some plans, you would give a file to a plotter and it would actually draw out your plan. So instead of it being printed in a raster fashion, like top to bottom, this thing would actually go and draw like all the elements in your drawing that was on your screen, but on a piece of paper. So I made a prepared plotter, and the idea was to change the way that this plotter functioned. The typical plotter functioned. And so this plotter had two kind of main components. One part, thank you. One part faithfully reproduced computer images. So if you had a drawing on your screen and you clicked print, this part of the machine, this part here, would like faithfully reproduce that drawing. So you could do like a tiny little drawing that was on your screen. But there was this other element here called the interrupter. And the interrupter would literally interrupt the drawing machine from drawing. And that might seem like a very uninteresting thing to do. And I myself thought this is a very strange project. But then it kind of created something unexpected. So these are a bunch of strips of paper of drawings that came out of the drawing machine, the prepared plotter. And on the far left, the interrupting machine is not interrupting. So, so we have the drawing exactly as it appears on the computer screen. But as we move more to the right, that drawing process has been interrupted. So literally, the paper has been pulled away from the mechanism that's trying to draw. Okay, so if you can imagine you're taking notes, and then somebody comes and pulls your notebook a little bit, and then you keep taking notes, and then they pull your notebook again, and you keep taking notes. You get this kind of exploded note-taking, right? So this is what we're seeing here. So in this image here, all of these lines are also in this image here. They're just stretched, if you like, in time, in the whatever axis you want to call that, in the vertical axis. So what this machine kind of like accidentally does is it kind of makes like a time-lapse drawing for us. It shows us the sequence in which a machine has decided to draw something that is on our screen. Does that make sense so far? Yeah? All right, cool. So just to be clear, so like if you have some kind of computer vector drawing made out of lines, you can stretch it, and then you can show the entire sequence that the machine is going to undertake to reproduce this image that's on your computer screen. So it's a this above here is a time lapse of this drawing on the bottom. And of course you can see that the computer kind of like draws different types of images differently, obviously. And you can see that some images kind of get distorted, but kind of retain some kind of like formal logic, whereas others get completely like torn to shreds and are just like sort of lose any kind of formal significance. So for instance, this is an elevation by a group of Japanese architects. It's made entirely, it's completely minimal, and it's just a series of square windows. And you can see that the windows kind of survive the exploding process. This is another facade of a building in New York, the Cooper Union facade, and it's made up of so many lines that divide the front facade that when it is stretched, it sort of becomes this like unraveled kind of mess and kind of loses any kind of like formal logic that it had previously. So I like to think of this machine as kind of showing us these images, which are iconic for architects. I like to think that it's showing these images through the eyes of the machine. All right. And So here's the little expo that we had with all these drawings. Did these drawings, put them on the wall. People loved it. This is the interest of doing this activity, which is that if you take a series of the same image, you can ask different algorithms to sequence those images in different ways. So just to be clear, on the bottom is the same drawing, but the explosion is showing the time lapse of the drawing process. It's showing the sequence in which all of the lines in the image on the bottom have been drawn. And so at the bottom, it looks like all these images are the same, but in fact, they're not. Well, I mean, they are, but they were drawn in completely different ways. So it's almost like in an instant snapshot, what this method or technique, like visual technique does, is it gives you an idea of the kind of like priority of the sequencing algorithm that's taking these drawings and is saying like, I'm gonna draw this like this. And very quickly you can kind of compare them. I mean, how much you can really learn from that? Like, I don't know, it's pretty limited. But you at least get some kind of like idea that this algorithm appears to be doing things from like left to right, and that seems to be different from whatever sequence this drawing has been drawn in. So yeah, anyways, so this is the idea, is to kind of like represent machine processes, which are typically difficult to understand, and to represent them visually. So that there's a kind of visual shorthand of the thinking or priority behind a sequencing process. Cool. All right. How's the energy level? How's the understanding of the Jonah talking level? Oh, whoa. All right. Triple thumbs up. Thank you. Okay, cool. So we were just talking about drawing. Again, going back in time to when your parents were my age. Back in that day, we had different types of screens. We had cathode ray tube. Have any of you seen a cathode ray tube ever before? Yeah. Okay. So it's like this vacuum, this glass, vacuum-filled piece of glass with electrons shooting around. And basically, you draw things on the screen really quickly. So if you want to draw a happy face, you draw a happy face, and then by the time you finish drawing, you need to go back and redraw it again. And you need to continuously draw and redraw images so that our eyes can actually see the image on the screen. So I wanted to slow down this process. So in a kind of similar way, I was interested in this specific moment that happens really quickly of screen rendering, and I wanted to understand how screen rendering worked. So I built another prepared instrument, and this was the first kind of electronic. Well, I mean, I guess the other one had some electronics, but this basically is a controller for a screen, a cathode ray tube screen. So you can load any kind of sequence of points you want in this, and then it will go through the points and it will draw the points on the screen. So I'll just show you. This is the circuit, okay? So in a similar way, so I took some of the same images that I had taken before with the other drawing machine, and the main difference between, so this is a time-lapse screen rendering of an image, okay? And I used that machine to slow down the drawing process, and then I used a camera that was taking a long exposure image that was mounted on a servo motor in order to take these exploded images. So the first thing you notice that's different is that these images are drawn and redrawn over and over again. So instead of drawing once something and it being there on the page, the machine is in this constant phase of drawing and redrawing. It's almost like a river flowing. It's like nature. It's like constant change. And you come in at some moment and observe this moving body of water, but it is kind of in constant flux. It is it is light. And so it has a kind of ethereal dimension to it. And the other thing that's fascinating is that it's taking place in time. And with this device I was showing you, that we can change the speed of that rendering. So at the bottom again is this one image of a facade, and then above is rendering that image but at different speeds. So, okay, so that's maybe not super interesting, but what I found cool was that I could also use this machine just to mess around with stuff. So so what I did was I just, like, all the little switches and knobs that I had on my machine to help my machine function properly, I just started like tweaking them without knowing what I was doing in a real like punk art kind of way. And then I just started recording some of the weirdness that I could create by like messing with all these parameters. So it was kind of like a synthesizer for images. And I got really excited by this idea that, in fact, around us, all around us, are machines like, I'm off screen, now I'm back on screen, are machines like this that have parameters that we can mess with. But the machines are just like in boxes. But if we could open the boxes, we could actually just mess with all of these machines. And instead of our machines doing what they've always been doing, we could sort of discover what else they're capable of doing and kind of bend them and maybe kind of learn more about their personalities in some way. Okay, cool. Sweet, sweet, sweet. Okay, yeah, we're good. So third thing, we're moving forward. We're making progress. All right. This lecture is all about progress. So I was going to do a live hacking demo, but that didn't work out because I got to use this computer. It got complicated. But I'm going to invite you all to do this exercise, or maybe I'll do like a workshop later. Basically, when you have an object in some 3D modeling environment, do you guys model in 3D? Someone here? Yeah, cool. What are some programs you use? Fusion. Rhino, SolidWorks, great. Okay, yeah, sweet, lovely. Okay, so for instance, if you make some kind of form in Rhino, and then you want to save it or export it into a file format, maybe for printing. 3D printing, so like a stereolithography file format, an STL. There's a kind of fascinating thing that happens. Whatever exists in your file, it appears all at once on our screen, but in the computer's eyes, it's like this really big fat book that it just reads really, really, really fast. So there's actually a sequence to everything that exists in your 3D model. If it's in triangles, there's actually a first triangle and a last triangle, and every triangle in between has a number, in this giant index. And if you ever want to check out this index, you can just open up an STL file in WordPad or Notebook or whatever, and you can actually just like see in text each triangle as it appears. And of course, you can mess around with that. And then you can save the file, and you can reopen it, and you can like explode your really weird models. So I basically came up with a very simple way of taking a 3D file and stretching it in time, stretching it in the Z axis to show the sequence in which it has been stored in the computer's memory, okay? So I have a bunch of triangles, and I just offset the triangles more and more as we go further down the file, and you get this exploded thing. And I made these exploded 3D prints. So what I would do is I would go online, and so you guys feel free to look at I'll pass them around or something. Basically, the bottom is some kind of found 3D model on the internet. And then above is that model exploded to show the sequence in which all the triangles in the model have been stored in some kind of computer memory, in the file, essentially. So this is like a time-lapse meshing process, if you like, of the model when it was exported into stereolithography file format. I've lost my thing. It's back. All right, we're back. We're under control. This is all under control. So again, you can make series of, you can find like any kind of series of object that you want to investigate, and then you can like explode these objects and then make a series. So these were, I was interested in buildings for a while. So I went online, I found random people's 3D models, and then I just started exploding them. And then I had this big file of like called explosions with a Z. And then anytime I liked an explosion, I would be like, okay, maybe I'll print this. And in the end, I had a bunch of models to print. And it was a lot of fun printing these. We were talking, Shao was talking earlier about John Cage's prepared piano. I took a piano because John Cage, and then I exploded that. And it was just really fun to take everyday objects. So for instance, here's a camera, here's a pencil sharpener, here's like some kind of crate. And what I found funny was that sometimes the kind of exploded vision of these models contrasted with our understanding of these objects in our day-to-day experience. So for instance, this was a car I found. And you can actually see that the majority of the file describes the treads on the tires. So it's cool. This is kind of like a centrifuge for data. You take a file, you spin it around, and then you see how much of the file is used to represent what aspect of the 3D model. So even though maybe we might think that the most complex and articulated part of a car might be like the engine block, or maybe the interface with the human inside the steering wheel, it's, according to this computer, the thing that requires the most attention to detail are the treads on the tires. And I like this kind of idea that a computer is seeing the world in a different way from us, and it's kind of like having difficulty perhaps matching itself with our kind of understanding of the world, and therefore creating kind of absurd moments of absurd misunderstanding. So this is maybe the most interesting thing that came out of this part of the project. You guys were talking about different 3D modeling programs you used. So I went to different 3D modeling programs and I made hemispheres. So kind of the most basic, well, I mean, I guess a cube is more basic. Anyways, I made hemispheres, all right? And then I stretched them in time. And with every program, I made the minimal hemisphere. So I made it with like the fewest number of triangles. So some of the minimal hemispheres are like taller than others because they won't, like some programs won't let you do less than like 1,000 triangles or whatever. So that's why there are different numbers of triangles in each hemisphere. But what I find interesting about this is that we can see that 3ds Max, Maya, and like Fusion, for instance, all kind of conceive of a sphere starting at the pole and then like unwrapping, like sort of like how you would unpeel an orange. Whereas SketchUp and Rhino, for instance, conceive of a hemisphere as a series of slices, like you would slice an orange. And so this is like a completely kind of insignificant detail. I don't think this has any impact on like functionally representing triangles in a rendering program, for instance. But I found it to be, again, a kind of moment where we could see some kind of idiosyncrasy at a very low technical level. And you might ask, like, well, why is there idiosyncrasy? It's because people are behind these designs. So I was briefly an artist in resident at Autodesk, which is the company that makes AutoCAD. And I got a chance to talk to the engineers who actually make these software programs. And Autodesk is kind of fascinating because it's buying up all these other tiny software companies. And everyone who is bought by Autodesk has to stay at Autodesk for 2 years. It's like a prison sentence. And so while I was there were all these kind of weird people floating around being like, I got bought by Autodesk, I'm here for 2 years. And it was this really weird vibe. But I was able to talk to them and be like, why did you, in your software program, why did you make a sphere like this rather than like that? And they were like, I don't know, I'm right-handed, so I go from the left to the right. Or, I don't know, like that's how I think of a sphere, is like slicing it. So it was just fascinating to see personality inside these software programs that I kind of think of as monolithic things without any kind of personhood. But here at this like really atomic level with some kind of completely arbitrary decision made by a group of people and a group of people who are white, male, who live pretty much all in San Francisco. So like kind of weird, like there's this like social dynamic. This one group of people is influencing the way we are representing form in some kind of virtual environment. That's like so absurd or odd. All right, yeah. Did everybody look at the, we didn't break, nobody broke them in half? Okay, thanks. Okay, cool. Well, so we've talked, like I talked a little bit about drawing, drawing from like a plotter, drawing by like on a screen, and then we went towards triangles, the sequence in which something is triangulated. I want to talk now about kind of like how to represent memory itself. Like how do you actually represent bits and bytes in the computer? So one very simple way of doing that is with Photoshop. Now, are my slides in the right order? We will see. Okay. So I don't know if you guys know this, but you can open up any file in RAW mode, and you can see that file. Like I'm talking about videos, movies, images, sound files. You can open that up in Photoshop as an image. And then you can start doing image modifications to that file. You can literally like smudge or change to, I mean, all this crazy effects that you can think of in Photoshop. You can also just like select a square or then copy and paste it in a bunch of places, and then save it back into a raw file format, and then open it back up by a movie program or a photo viewer or a text file or a sound playing device, software. And you'll hear all these completely transformed files. So again, this is kind of going back to the materiality of the medium, I guess. So we were talking about John Cage like getting his hands inside the piano, actually putting material things that change the way that the strings are vibrating. Here we can kind of get a feeling for the grain of data. And so these are a bunch of kind of random things I found on the internet, and I was just struck by the patterns. I just liked the patterns that they made. They almost look like an Annie Albers work of like a, it's not sewing, it's knitting. And I found that there were like different things that you could observe and you could learn from these files when you looked at them as images. And so I should have mentioned, but essentially each byte is converted into some shade of gray. That's how we're interpreting bytes here. So each pixel is a byte, and the shade of gray of the pixel is the byte value. So this is really cool. This is a type of file that has like a flexible structure. So like you can save some data with like more digits after the decimal point. Thank you. And as a result, instead of there being like a super regular pattern of data, there's like some data that's longer and some data that's shorter. So that's a variable length, null terminated set of data. So basically, the system, I mean, I'm totally guessing because I have no like actual, but it would appear that these two black dots and then the white dot is like a signal to say this is the end of the data that I started telling you about before. So this obviously is a file structure that allows like more flexible types of data to be saved with like varying lengths. And then on the other side, you have fixed length data types. So here you can see structures that are very regular. So here it's not flexible. We can't change the amount of numbers after the decimal point in this data structure. But maybe that's not interesting because maybe this is a certain type of file where that's not valuable to us. So I really like how there's some kind of insight that can be gleaned from visually representing data. Am I losing you? Are we, yeah, all right. I'm seeing there's just like hesitation. There's like, yeah, but I want to eat things. Well, when did we start? Are we going long? Okay. Last project. We made it to the last project. Cool. So I mentioned before that with this device, with this device, I became really excited by the possibility of messing around with buttons and knobs to kind of like deform images. And I came back to that as a kind of practice. And I made this prepared memory device. And so this is like a screen buffer. So in your computers, you have like a little part of memory, and when you want to put an image on the screen, your computer sends it a bunch of pixels, and those pixels get put in this special little memory spot before it gets sent to the screen. So I made my own little miniature screen buffer, except for all of the parameters that you could possibly imagine changing, I put a knob next to them, basically. And then I went back and did this activity again of like deforming images. And of course, this is a different type of screen. So the screen that I was messing with before was a screen that drew with like a photon gun. This is a raster screen. So this is like a pixel, this is like your computer monitor today, where there's a bunch of pixels that are drawn like 60 times per second. So there's a different quality to the type of distortion you can create with this machine. But again, I'm not even like making the machine malfunction so much as just like pushing it to the edges of its comfort zone, and it's producing these images which speak to the experience of the machine while it's like really uncomfortable trying to do what I'm asking it to do. I made another video synthesis device that modifies this memory, and it modifies it purely with logic, with pure logic. So just logic gates, transistors that are taking these saved memory screen buffer data sets and are modifying them, but like live. And you'll notice that I started going towards color. So up until now, I've been in the black and white world. But I'm free now. I can express myself in other ways. I'm not limited to just shades of gray. So anyways, so now it's a different type of activity, exploring like the character of this new medium, this like the pixel screen. And I think that takes us to the end. I have a couple takeaways for those who weren't taking notes. So okay, one thing I wanted to say really quickly is that software is like a total mess. And we have this idea, I think, as users sometimes, that you double click on a program and then like the logo comes up, and then you enter into this like comfortable space. You're like, hi, file, hi, new folder. And everything is really seamless, except for behind the scenes. There are a ton of like little scraps of things that have been like kind of duct taped together. And this is the reality of most software. And why is that? There are a bunch of reasons. Developers have to make stuff fast. There's no money for infrastructure. There's no money to fix stuff and make it cleaner. There's a bunch of programs that have been built like in the 60s, yes, and have been like ported to new, each time a coding paradigm has changed, they have just been ported blindly by some kind of machine. And we don't actually know how they will behave in new environments. So the idea of software as this pure mathematical space, that's not the case. It's like this messy social zone. It's like a quilt that's been handed down from like family to family with like holes in it. I mentioned before like one insight for me, which was that when we see things on a screen, for instance, we see them existing all at once, kind of like all the elements on the screen at once. But again, a computer is actually just like reading this book extremely fast, going through each page, each element, because most things in the computer are indexed in some way. And that's to understand how the computer sees things, you would have to understand this sequential way of reading memory. So I found that interesting. And finally, there's a lot of decision making on my part to show certain images and not others. So I had, in my explorations of this virtual space, I was particularly drawn to moments that kind of push towards chaos or strange oddity. But you could also approach this space, and with a different curatorial priority, you could also find examples of very simple, pretty things, perhaps. So there's also a lot of bias in everything that I've showed you is like what I want to find in this mysterious world. But perhaps you will find other things, or perhaps you will see other things. All right, yeah. Final slide. No more slides. Thank you so much, guys.